Hello, welcome back. I'm sure you enjoyed that break. Now let's get into the STM32 by IDE and let's learn line by line about to code this program. So I got all the hardware setup connected here. As you can see, we'll check the output soon. I'll minimize this. I already opened the STM32 by IDE. Before doing that, you have to create a folder called Bluetooth and save that in your desktop, and create another folder called target. And also you need to go to STM32 and download this firmware F4V, because we're going to include the built-in header files. So remember, from the LCD onwards we were doing the built-in header files. So these files live in here and you need to have this on the same folder as you are working on the project. So click on the target and go here and copy this path, and you need to go and change the workspace because you're going to work on that. So go to file, go to switch workspace, go to other, and then paste this link. Make sure it's on the Bluetooth target, yes, and then launch. This will change to the current workspace where we're going to write the program line by line. It will take a while, as you can see. Once it's ready, then it will let us to choose the board selector, which is the STM32F411RE. It's loading up in the background. Once it's ready, then we will continue with the programming. And we got to include two paths and the symbol, so we got to do all of that, and then we will get into the programming. Just give me a sec, it's downloading in the background. Once it's ready, then I can share you. Yeah, it's downloaded, and you don't need this information center, so just close, and you go file, new, STM32 project, and this will take some time to give us the necessary files so we can start the program. Because we are opening as a new project, so always it will take a while to get it going. So it's doing something on the background, so that's why it's not responding. So once it responds, then we will go and finish the path links on the symbol generation. Then we can go and do the programming. It's still doing its connections here. It's still checking, as you can see. On the background also, it's downloading a lot of files, and it's connecting to the HTTP server. Once it's ready, then it will let us to choose the board selection. Yeah, now it should let us to use the board. Let's wait for it to finish the target selection, then we can continue with the program. Okay, so you know the drill. Go to board selector, and then in the commercial part number, just type nucleo dash F411RE, and then choose that board. This is that board. Click on next, and then just give a project name. We are on day 28, so I'll give us day 28 Bluetooth automation. And then we are learning from writing from scratch. So select as empty for the targeted project type and click finish. The project already created, and within few minutes it will give us the necessary files that we are after. It's 50% at the now. Yeah, so all the files came through. That's good. So go on to source. We got to wait, it's still 50%. Once it's ready, then we'll get the main.c. So it's on 83% now. It has to link with a lot of built-in functions, so that's why. Okay, so that's the main. Open the main and delete unwanted lines, the default lines. And I will make it bigger so you can see the screen better. Yeah, so I'll delete all of this, and also you don't need this. So we're going to include the built-in header files. So as you know, the header files has to be included with codes. So it is stm32f4xx.h. Hash include stm32f4xxh. Yeah. Still doing some internal checks, just wait please. As you can see here, it's still connecting. Okay, I haven't connected my hardware, so that's why it's taking its time. So now I'll just simply connect my hardware, so it will detect, otherwise it will show the error. Yeah, I connected the hardware. I'll go and save. It's checking. Yeah, it's showing some syntax unresolved inclusion. That's okay because we haven't done the path. So just going here, right click and build the project, because we got to include those files. So it will come up with the errors here. We got to wait. Yeah, so you'll get 3 errors. So we got to do 2 paths and 1 symbol, and this error will eliminate. To do that, you need to go to the folder where you're working on the Bluetooth folder. Go to stm32cube.ide, the firmware of version, and go to drivers, cmsys, go to device, stm32f4x, and include this file, and make sure the stm32f411 is here. Yeah, so copy this path, come here, copy this path, go to the IDE, right click on the project name, go to properties, wait for the properties windows to open. Then in the properties, go to C++ build. As you know from the previous sessions, go to settings, in the settings, go to MCU GCC compiler and click on include paths. Come here, add the directory path. So paste it and then hit OK. That's added. So you need to copy another folder as well. So go back to the folder again, and this time you got to copy the core. When it is ready, it will let us to copy the core, so we can do the core copying. So you have to come all the way to core on CMSys, include, and we need to include, make sure this core cm4.h is here. Good. Copy this path and do the same thing. Right click, go to properties, go to C, C++ build, go to settings, go to MCU GCC compiler, go to include paths, and come here, click on add, and just paste this core. Okay, so both included. So click on apply, yes, and then apply and close. This will close it. So again, you can go and save, and you can build the project once more. It will also still throw some error because we haven't done the symbol declaration. So right click on here, open declaration, and then scroll all the way down to go and copy this symbol STM32F411XC. So copy this, right click on the project name, go again to properties and C++ build, settings, MCU GCC compiler. This time go to preprocessor. As you can see, it is not added here, it's debug, and as soon as I add, you will see on the after debug. So click on add, define symbols, Control A, Control V. So this will be added. STM32F411XC will be added. Apply, yes, and then apply and close. Okay, and you don't need this for now. So again, you go and build the project. So now the path will be set and it will be error free, and we can start to write our codings. So we done our first part, so that's on 0 errors, 0 warnings, which is always good. So now we can go and build line by line project now. To do that, first you got to initialize the UART, because we're going to initialize, we're going to use the USART. So I'll go and write a function void. We're going to use USART1. So I will use USART1 of init, and copy the same function. Copy the same function. And you got to write what's inside the function. So first, as you know, we're going to use USART1 and PB6 and PB7 and PA5. So you got to enable clock access to GPIO A and GPIO B. GPIO A and GPIO B. So to do that, you need to use the RCC AHP1ENR. So RCC AHB1ENR AHB1ENR. You need to enable this. enable the 0 bit and the first bit. I'll show you where it is. One unsigned of 0. So this is for GPIO A, and I'll copy this and use the same statement for the GPIO B as well. So copy this and I'll change this as 1. So we just enable the clock access. I will open my reference manual and I can show you where this is, just to recap with you so you would know. It's just opening. Just one sec. Then the next step is to enable the peripheral clock bus. Keep losing my mouse, sorry. The next step is to enable clock access for peripheral bus, which is RCC, because we are using USART1, so it's connected to APP2 ENR. So you got to add that, and the bit is 4th bit. You got on this 4th bit. Yeah. I'm still trying to open my reference manual so I can show that to you. Just one sec. So after selecting the clock axis, then the next step is you need to set alternate functions. Sorry, I'm just changing battery on my mouse. Just one sec, sorry, because I'm losing. I'm losing my mouse all the time, so just swap to another battery. Okay, battery is ready. So the next step, you got to set for alternate functions, which set alt functions for PB6 and PB5. Alt functions it is PB6 and PB7. This is where you're going to use the TX and RX. TX and RX. And you're going to use the motor register for that. So first GPIO B, then you're going to use the motor register. You're going to write 0111. Sorry, first we are using alternate function which is connected to the TX and RX, so you need to use 01 in the motor register. So the registers we are using is 13th bit and the 14th bit. 13 and GPIO B, you got to write 10 motor. So you can't write 0, you need to AND that and negate to make it as 0 for the 12th bit. I'll show you once my reference manual opens, then you'll have a clear understanding. So you need, that's for PB6. Also I need to do the same for PB7 as well. So I'll just simply copy those two and save it, and I'll just change the bits. So this will be 15 and 14. This will be 15 and this will be 14. Okay, so the next step, now you connected the Bluetooth with the TX and the RX. Now you got to set PF5 to connect to your GPIO. In this case, we are going to control a DC fan. So set, we are using port A5. Set PF5 to connect to relay. To connect to relay. As output. So that means bit 10, 11 as being output is 10. So you got to copy just the above two statements, and you have to change 10 and 11. So I'll copy the above two GPIO motor and come here, and this will be GPIO A, GPIO A motor, and also this one GPIO A motor, and these two bits will be 10 and 11. This is 11th bit and this is 10th bit. Once I finish the program, then I'll go to the reference manual and I'll show you exactly what I'm doing, so you would understand as well. So now we set the motor as the output. So the next step, we need to link the AFR registers with the alternate function. So configuring the AFR registers, configure AFR registers, and in the alternate function table it's linked with AF07 as we are using PB6 comma PB7, that is bits 27, 26, 25, 24. Being AF07, you got to write 0, 1, 1, 1, and for PB7 bits 31, 30, 29, 28, you got to write as 0, 1, 1, 1. So this is what we're going to do the next step. So GPIO B, it lives in the AFR lower register, AFR of 0, and you're going to set 0, 1, 1, 1. So 24, 25, 26. So first you got to set one U. This is for the 24th bit. And we will need all of this. I will change it once I come here. Copy, paste it. So this will be copy this. Copy the whole. Sorry, I keep losing my mouse. I will use the mouse here. Copy the whole. Control C, and I have to change all of this to A for zeros. A for 0 and A for we don't need this, so I'll delete this line. GPA will be and I will copy this. I will change this to A for 0 register as well, and this one A for 0 register. I'm doing it for first PB6. A for register, paste, and this will be bit what, 27. 27. This will be 25. This will be 26. This will be 26. Okay, so we did the for PB6. We have to copy for I'll just copy this and paste and use it for PB7 as well. So copy this, come down, I'll do this, backspace. This is for PB7. And this will be 28, 29, this is 30, and this will be 31. Yeah. So we now configure the GPIO bits. So now we need to connect to the TRE, that is the transmit enable, and RE enable, and the USART enable. So to do that, you need to use the registers. Now link TE, receive enable and USART enable. And set T to To do that, you need to use usart1 of control register 1. I'll show you all the bits because it will confuse you. This is on the 13th bit, and you need to enable the second and the third bit as well. That's for the TE and RE. 13th bit is for the usart enable, and we're going to enable the transmit enable and the receive enable. So I'll copy once and twice. First I will enable the receive enable, and this will be the transmit enable. Yeah. Now the next step is you need to include the baud rate generator that we calculated using 16 megahertz. You need to include that here, the baud rate as 9600. To do that, you need to use this register, usart1 of baud rate register, and you got to write the value, hex value 0683. Okay, so go and save and right click and check for errors at this time, just to make sure we are doing okay. So I will save and go and right click on the project and build the project, check for errors. It's going through. It may show an error because we didn't call the function in the main program, which I'll fix it, but we'll do the usart read and usart write, and then we'll go and do the build project. So it's on 23%, as you can see. 27, it's moving. Is on 98%, so it is done. That is good. So now we're going to go and write the usart read and write functions. To do that, you got to go and write two more functions for read and write, which I will create it here. Void usart1 underscore read of, we are not sending any parameters, so I'll leave it as that. Usart1 read, then I'll write another function for write as well, your write, and for the write you're going to send the data, so car data, capital C, small c, lowercase c, car data. Okay, first we'll start with the void usart1 read function. Read. So what is in the read function, you got to check first. You're going to check while of not equal to USART1 with the status register. USART1 with the status register, and you're just simply going to AND that with this value. I'll explain with the value why I'm writing 80 once I open the reference manual, and then we got to wait until the bit is set. Wait until the bit is set. So once it's set, then you just call the USART1, pass the data through the data register, and simply just AND with 8-bit data with 8-bit. Data. Okay, so that's all we're going to do in the read, and now we're going to include the write. So void, next step, void USART1 underscore write of car data. So what are you going to write in the USART write? You're going to check for the bit is set or not. For the transmitter bit, that's the RxNE bit, and for the write you got to check for the for the read, this value should be 0020. I'll explain, don't panic. So this is for RxNE set or not. This is for the TXE set. Then once it is set, okay, sorry, this is supposed to be right. Once it's set, then here in the read we are just returning the data, that's all. You don't have to pass anything, so just return USART1 of data register. Yeah, so we did that. Now I'll go and fix the main program so you won't get any error this time. So go to main, and I need to create a global variable, a local variable. So car of data. Then this time I'm going to call the init, and I'm going to write USART1 underscore write. If it is A, that means fan power is on. Any other character, then it won't be on. So then write a simple while loop to check the condition. What are you going to check? You're going to check data is read or not first. USART1 underscore read first. What to read? If data equals A, single quotes, A, then do this. indented so you won't get confused, and do this else to something else. So if data is equals a, then what it want to check, then go to GPIO a, that's where the fan is connected. So output data register, you need to just simply first turning it on. So you got to just negate that with the bit 1, because we connected to PA5, so that's why we are doing 5th bit. Yeah, then for the else condition, so come here, also what the user write have to do is that 1 underscore write is just get the data. That means transmit character. Okay. Or else, if this, then else GPIO A OA ODR is going to set this time. Fifth bit. Then once it's done, then write the data. Is that 1 underscore write of data. So I think we finished the program that we want to write and transmit. Now let's go and build the project and do the debug, and we can check the output. So we don't need this. I'll delete that. Okay. I will go and save the project, and then you need to compile and do the debug. Right click, build the project. Why is that one read of return of usert1. Okay, so return of usert1. What is the error? Just checking, it's throwing some error on the usert1 read. Return of usert1 of data register, that is good. Okay, we are checking with the status register while off. Then we are just simply waiting for data. I'll check what the declared here. Okay. Return with the value in function returning void type. Okay. User data usert1 of read void value not ignored as it ought to be 1. So data is coming through usert1. It's a read data, that's the usert3. Sorry, spelling mistake. Sorry guys, it's a simple error, see. So it's supposed to be usert, not userat. USART. Usert1 underscore read, usert1 underscore usert1 underscore read, usert1 underscore init, usert. Oh, I typed it correctly here. Usert1 read. Okay. Now save and compile. Save. Right click and do the build project build. So this should clear the error because of the typo. Once it clears, then we'll change to debug and we'll check with the download of the program, and also by this time you also enable the data as well. So what did I miss there? Data is usert read. Character data, so we are writing the same character data here, usert1 write for the usert1 this is closed and that's closed. So data is usert1 underscore read off, and when you go here usert1 underscore read off, it's just while with the returning with a value which is this. Okay, I will give you a short break, so please go and have a break. When you come back, we'll go through this error and also we'll check the output. So please go and have a few minutes break. I will see you shortly in about a couple of minutes. So see you then.